Okay, on the problems here for calculating a correlation, the easiest thing to do that I've always done is to just use Excel spreadsheet. That way I know my numbers add up. And so you're going to have a column with your X and your Y. And so even in this first column, I had just written the number in here, but you didn't even need this. This column right here is sort of like your A, B, C's, and D's. So that column is completely unnecessary. It just lets you know how many places you have here. Alright, so I've got X and Y. You've got an X squared column, a Y squared column, and an X times Y. You sum up each of these columns, and then you go down to your formula and drop them in. So where it says the sum of x, y, and here, let me get back to the formula so I can show you a copy of the actual formula from the book, or I think I have another copy of it. Let's just go over here. So we're looking for the sum of x, y. If you go back here, that is literally this right here. The sum of x, y, and some of you made this, we're making this. The sum of x, y is this column right here. It is not x times y. Some other people had actually done this x, 62 times 29.4. The sum of x times y is literally x times y, and then sum up all of these, it's 189. So that'll be your first term, 189. The second term is n, which is a given, right? We know n is 10 in this problem. And then x bar and y bar. And let me say about x bar and y bar. X bar is 6.2. Don't round this to 6 or round the 2.94 to 3. A couple of people did that. And because r must be between -1 and 1, right? Let's see. R will always be between 1 and -1, right? So because r is between here, it's such a fine space that if you do some rounding here, because according to page 17, you never want to round ahead of time. You always want to round at the end. And so if you round in the beginning, you'll end up with an r that's very off, and you could potentially reject something that you probably should have failed to reject. All right? Then on the bottom term here is simply the sum of x squared, right? The sum of x squared, you get the sum of x squared from going up here to the x squared column. The sum of x squared is 412. So 412 minus n times x bar squared. And the next term is just going to be simply y squared, the sum of y squared. Let me show you this one. The way I write it out is the sum of y squared, if you can read that. The sum of y squared minus 10 times y bar squared. Alright, now when you're doing your math, I noticed a couple people had this problem. Here, you want to square 2.94 squared, then you multiply it by 10. Okay, you don't want to multiply 10 times 2.94 and then square it. You want to do 2.94, square it, and then multiply by 10. Following out, I've got 189.2 minus 182.28. That goes to 6.92, and in my denominator, I'm going to have 412 minus 384.4, and then here, 89.12 minus 86.436. I've got 27.6 times 2.684. Carry that down here. I've got the square root of 74.02, 6.92 divided by 8.60688. And notice how I carry out. I know it's a pain, but it'll work out better. And then you got the 0.804. Now, as far as doing a t-test, the book goes into how to do a t-test on these. However, on page 263, it says a t-test is unnecessary. Simply use the table F in Appendix C and compare that to 0.804. So if I go back into the table, I come up with, they've given me an alpha of 0.05 and an alpha of 0.01, right? So it gives me 0.6315 and a 0.7646. I went ahead and shaded in all this in my rejection region. And then when I look on 0.804, it's clearly in the rejection region, so you can reject the null. There is a relationship between GPA and satisfaction. Okay? On the other problem, just want to go over it and set up exactly the same way, except this time I did not use Excel. Let me get a clear view of that. Okay, and I'm going to scan both of these. But the key here is to know what these terms mean. The sum of x times y is literally, you take every single x times y and then you sum them up. That's this column here. I got 80 by taking 10 times 8. I got 48 by taking 8 times 6. You sum all these up. So I have 250 minus n, which is a given, right? 11, times x bar and y bar. Let me stress again, 45 divided by 11 is not 4.1. It is 4.09, and the same thing with the y bar. It's not 5.5, it's 5.45. If you notice, if you use 4.1 and 5.5 here, you somehow get an r of 0.01. Now, given that again that r must be between -1 and 1, by rounding before we even start here, you're going to end up way off, and so you could potentially reject something you should not have rejected. All right. Remember, r is just simply a correlation. Alright, so given the 0.0421, we would say that this is a positive correlation between the variables of x and y. And just so you can see how I graphed it, kind of came in here, I've got all my points, and my little line is just a really kind of weak sort of line going through there.